Today I will explain one of the optimization technique. So how we can handle the data skewness by using a salting method. Okay. So what is data skewness? Suppose we have a uneven distribution data in the data frame, then you will get a data skewness by doing aggregation and join. By doing these things, right, we will get data skewness. When if we have a uneven distribution data present in data frame. Here, suppose we have 1 millions of ones and only three of twos and only three of threes. Okay, this is like a uneven distribution, right? So, suppose see this is partition one. Okay, this is partition two. So, this is partition three. Okay, all the ones will come and sit in partition one. All the twos, right? So will come on partition 2. All the three will come on partition 3. So when you do the transformation, right? So P2 and P3 will complete as soon as possible. So partition 1, right? It keep on running. So then we'll identify this is a bit skewed. So how we can know these all ones sit in partition 1, these are partition 2 only. So we have a in Spark we have a hash algorithm. Okay, so that is hash of value of mode shuffle partition. Okay, if here suppose our shuffle partition is 3, consider. So hash of 1 mod of 3 is equal to 1. So all the ones should go and sit in here partition 1. Okay, hash of 2 mod 3 is equal to all the twos, right? It go and sit in partition 2. So like this data will be placed in the partition. Okay. So when you will get the data skewness, uneven distribution of data present in the data frame, then we will get a data skewness. So now how we can, suppose I will show how it will be. So see, in this data frame, suppose this thing has a data frame 2, here data frame 1. Okay. So here evenly distribution of data, right? So here uneven distribution of the data. So here partition 0 contain this 1 millions recording present in the partition 1. Okay, so in this scenario we will get a data skewness. So one of the tasks will keep on running. Okay, so how we can resolve by using salting method. Okay, we can do repartition also. So and salting as well. Okay, so today I will explain how we can resolve data skewness by salting technique. So salting technique is nothing but just we are adding a random number to the one of the column. Okay, so I will explain. So here I am giving the shuffle partition is equal to 3 and I am disabling the adaptive query. Okay. So then we will get to know how we can handle the data skewness by using salting technique. Okay. So here I am generating the unique number. Okay. So here 1 million rows. Okay. This DF uniform data frame. Okay. So when you okay, here we delete generate. So once data frame is created, right? So how we can know how many partitions are there and each partition contain this much of row using the Spark partition ID, we can able to identify how many rows present in each partition. So to find out in which data frame how many partitions are present. So then we'll get we have one code is there get RDD. So RDD dot get number of partition. Okay, so this will give the how many partition present in particular. Okay, so total 8 partition. Under each partition how many record will be present we need to find out by using spark partition id. Okay, so here we find out. So here we got to know, right, this is evenly distributed data. Okay, so in this data 8 partition is there, all the 8 partition equal number of rows present. So here we will generate a uneven distribution of the data. So here partition 0 contain 1 million nearly, then 15, partition 2 10, partition 3 5 records. Okay, here like a uneven distribution of the data. Okay, then I will print it. So here, zeroth partition contains nearly 1 million of data. All other are uneven. So this is the example of uneven distribution of the data. So here we have uniform distribution of data. Okay. While doing join, right? So we will get a data skewness. Okay. So here we can join. This is a skewed data. This is a uniform data. We are doing an inner join. Got it, right? When you do the inner join, right? So here we will get a data skewness. Okay. So how we can get to know whether data skewed or not? So using partition ID, spark.partition ID, right? So it will give you the output. So each partition, how many rows are present? See, in 0th rows we have this many record, and 1st row these are 15th record. So and even in web UI also we can able to see. So this particular task taking too much of time. Okay, one of the partition is taking too much of time. Like this, we can able to see here. This is Spark UI. Okay, so here we can able to see the how DAG it actually works and all. So see here, one of the partition is taking too long time. Okay, based on this, we can able to identify. So data will be skewed. So how we can resolve the data skewness? Okay, so using a salt technique. So here we need to select the salt number. So salt number we are always we need to select the lesser or equal to shuffle partition. So here we are giving shuffle partition 3, right? So here we can select the salt number. Okay. So after selecting the salt number, we need to create one more column and assign to that random number based on the salt number. Okay. If suppose 3 is the salt number. Okay. Suppose 3 is the salt number. Okay. So then 0 to 3. 0 inclusion, 3 exclusion. Okay. So like this, we need to assign 0, 1, 2 to the salt number. Okay. Here we are assigning 0, 1, 2. Okay. Got it, right? So we are assigning random. So this will generate the random number from 0 to 1. Okay. 0.1 float, it will generate the float number 0.1 to 0.9. So here we are casting one integer. Got it, right? So it will generate the, we are just now we are assigning one unique number to the one column. Okay, random number. So similarly, we need to do the same thing for this data frame also. Okay, so then we can able to join. So this data frame also we need to create a one salt column, and here also we need to create a salt column. Okay, then we can join with the salt and values primary key. Okay, so this is the uniform data. So here I'm creating array of salt. So salt number is equal to 3, right? 3 is the exclusion. So here we are creating an array and you are assigning to one column. So explode will create a, it is a costly operation. It will create a number of rows respect to present in the array. So whatever present in the array, right? Suppose in this array, right, salt value 0, 1, 2, 3, 0, 1, 2. So it will create 0, 1, 2, 3 rows. Okay, that is useful of expand. It is a costly operation. Okay, so you how we can explain in the sense. See, initially we have all hash algorithm, right? Hash value of mode shuffle partition. Okay, so before hash 1 mode of 3. So all the ones should go to 1, right? So when we do the salting, right, then we will get hash of value comma salt mode of 3 means shuffle partition. Okay, here value 1 comma salt 0 mode of 3. Okay, 0 1 comma 1 shuffle partition 3, then 1, then hash of 1 comma 2 mode of 3, then 2. Okay, it will create rows. So then we can join with the value unsolved. Got it, right? So here we can able to join. Once we join, right? So let's see the partition, how much partition is created and how much each partition contain the data. So here see each partition contain evenly. Okay. So this is the way we can able to resolve the data skewness by using solve technique.